students, welcome to the video. Our today's topic is law of gravitation or law of universal gravitation. Students, this law was presented by a famous scientist, Newton. This law states every body in this universe attracts every other body with a force which is directly proportional to product of masses of the bodies and inversely proportional to square of the distance between their centers. This law simply says that in this universe around us, everything is attracting every other thing. On what factors does this force of attraction depend? To understand it, let us consider the example of two bodies of masses m1 and m2 are placed at a distance r between their centers. Students, these bodies will attract each other according to the law of gravitation. On what factors this force of attraction between them depends? First part of the law says this force is directly proportional to product of masses of the bodies. It means more are the masses, more is the force. Product shows that if either of the mass is increased, the force increases. When both are increased, force increases more. Secondly, the law says this force of attraction between these two objects is inversely proportional to square of the distance between their centers. It means closer the bodies, more will be the force. Inverse relation shows that if you increase one quantity, the other decreases. If you decrease one quantity, the other increases. Such a relation is called inverse relation. So students, here the relation between the distance between two objects and force is a inverse relation. Means if for an example, if we make the distance between two bodies double, the force reduces to 1/4. Or on the other hand, if we reduce the distance between two bodies to half, the force becomes 4 times. This is called the inverse relation between force and the distance between two objects. Now students, we combine these two mathematical relations. When we combine them, we get this famous form of Newton's law of gravitation, in which sign of proportionality is replaced with sign of equality. You know, the students of science, that whenever we replace sign of proportionality with an sign of equality, then we multiply on the right side with some constant. So students, capital G in this relation is called universal gravitational constant. What is G? G is universal gravitational constant. Now, this law, the mathematical form of this law, shows that force is directly proportional to product of masses, where m1, m2 are the masses of the two bodies, again, and inversely proportional to square of the distance between their centers, r square. And what is G? I told you it is a universal gravitational constant, and students, its value is 6.67 10⁻⁻11 Newton meter square per kilogram square. These units are obtained when we rearrange this equation to find the value of G. R will move on the left side, where it will be multiplied with force, and masses will, when move on the left side, they will divide the force. So units will get formed like this: Newton meter square per kilogram square. It is very important to remember this value of G along with its units. You may be asked this value in your Viva questions. Now students, what are the conclusions? This is the statement: F is equals to G m1 m2 over r square. What happens when the values of these variables change? G is constant except G. When m1 changes or m2 changes or distance changes, what happens? Students, when first we discuss the role of masses. If we make the masses increase, or if we increase the masses, then what happens? The relation shows that the force increases. Either of the masses when increased, force also increases. When both are increased, force increases more. Secondly, role of distance. What happens when the bodies are moved toward each other and get close to each other? then the force of attraction increases. This is related with an inverse relation. Force increases by decreasing the distance and force decreases by increasing the distance. Third thing is role of G. G is constant. Its value remains same, but its value is very small, 10 raised to the power minus 11. So we do not feel the gravitational force among each other in our everyday life. However, students, there is a situation in which we feel this force. When, think for a moment, when someone falls, he is being attracted by earth. So now earth is one body and second body is that falling person. In this case, mass of earth is very heavy and it compensates the smaller value of G, so we feel that force as our weight. Lastly, students, it is evident from this equation that it is a non-screenable force. What do you mean by this? When some screen is placed between two objects, the force of attraction is not affected. Students, this is all about the Newton's law of universal gravitation. If you liked the video, don't forget to subscribe the channel. Thank you for sparing your time to watch the video. Take care of you. Goodbye.